this session will explore the technical and practical aspects of creating sustainable, habitable environments for human colonization on these celestial bodies. So, as I mentioned, Mr. Reggie Pillai, President ISGF, will be chairing the session, and joining us virtually, Mr. Sameer L. Sayari, architect and researcher on outer space architecture, Mr. Michael Potter, founder Geeks Without Frontiers and senior fellow International Institute of Space and Commerce, and Mr. Madhu Thangavali, professor of the University of Southern California. A very warm welcome to all our speakers. Thank you so much for joining with us for this session. And without any further ado, Mr. Pillai, may I request you to kindly take over.
Good morning to Professor Potter, Professor Madhu Thangavelu. Sorry for keeping you waiting and making you wake up at 4 o'clock in the morning in California. Apologies, we will get started right away. And Professor Sameer, good afternoon to you. Thank you very much for joining this interesting session. We will be talking about architecture, energy systems for space applications, or when we colonize the moon or the Mars. In the entire solar system, the only source of energy is the sun. Autotrophs take it from the sun directly. Heterotrophs take it from autotrophs. In the course of evolution, autotrophs stored energy which heterotrophs stolen or accessed it and consumed it. About 400,000 years ago, Homo sapiens or Homo erectus in China mastered the art of controlling fire. Before that, fire was scary. They used to run away from fire. But once they knew how to control fire, they could use it for sharpening the weapon or softening the meat, cooking, agriculture, everything started from that point onwards. So interestingly, among millions of species on Earth, we are the only species which can consume energy outside of our body. It is called extrasomatic consumption of energy. The extrasomatic of consumption of energy multiplied in geometric proportion. And the more energy we consumed, the more population growth happened. In 1798, Malthus, in his famous essay, he said population grows in geometric proportion while resources to support the population grows only in arithmetic proportion. With agriculture, assured food supply, other developments in energy systems as well as in medicine and other scientific improvements, lifespan increased, population multiplied, from millions it became billions. Energy sources started depleting. Even although I said extrasomatic consumption dates back to close to 400,000 years, but last 200 years after the Industrial Revolution, that started increasing. Extrasomatic consumption of energy on the planet by Homo sapiens has skyrocketed to the extent that we may not have much left very soon. We talk about renewable. Again, in what time scale is it renewable? Petrol, you use it, once you use it's over. It's not there for tomorrow, it's over. Whatever 1 liter you used or 1 gallon you used is gone. Solar energy, we call it as renewable because sun will come again tomorrow. But on another time scale, today's forest can be few million years down the line fuel. It can be petroleum. But look at another time scale, few billion years down the line, the sun itself may not be there. What are we talking about? So, coming back to the energy consumption, David Price, in his very famous essay on energy and human development in 1992, he calculated, that time the population was somewhere around 5.5 billion people. The total energy consumed, I'm not talking just about electricity, the total energy consumed on the planet, he calculated, divided by 5.5, it came to something similar to every adult having 100 odd energy slaves. 100 odd energy slaves each one of us having. But today, total energy consumed on the planet divided by the 8 billion population, it could be few hundred energy slaves for each one of us. Is it sustainable? No, not at all. So let me come back to present. When I came to Delhi 40 years ago, Delhi's population was 40 million people. Today it is close to 4 million. Delhi's population was just 4 million 40 years ago. Today it is close to 30 million in 40 years. Delhi has become the most polluted city on earth. And my doctors have told me my lungs cannot handle Delhi air in winter. I must leave Delhi from October to March every year. So which perhaps I have to resort to doing that. So it's again on another time scale, maybe few decades or a century down the line, perhaps all of us need to leave planet Earth or Mother Earth. We need to look for, and many people talk about once upon a time there were population in Venus or in other planets which are more closest to Sun. So if we have to leave Earth, which are the planets which are conducive for us to go? Because we are already, as I said, 400,000 years ago we lived with whatever we could eat. But today we are all pampered with all the systems. Where can we go? What we can build? How can we survive? That's a topic. So I will first give a opening 10 minutes to each three of you, and then maybe Professor Sarai, Samir can do the presentation and then come to each one of you. So over to you, Madhu sir, first.
Thank you for the conversations I heard.
Do a little bit louder. We just you come over with a whisper.
Thank you, Reggie, for the invitation. It's good to hear the discussions going on, because India is on center stage right now. Many reasons. I just heard that the foreign ministers of the United States, Russia, and China are right there in New Delhi. I don't want to impress upon you the importance of India in the global stage. For this session, I was asked to talk about energy systems and architectures for the Moon and Mars. But for the past few years, we've been looking at how to apply the architectures and energy systems we use for human activity in space, to apply them to the problems of planet Earth. And so I brought up some slides. I won't talk to all of them. I'll quickly go through them, but bear with me. So I teach at the University of Southern California, and we have an astronautical engineering program that is globally accessible. And it's a growing program, but it's a young program. Within the astronautics program, yours truly has a studio, which is a combination of architecture and engineering, and the focus is literally on creativity, creating new ideas. For the spiritually inclined among us, you would say the activity that Brahma initiates in our universe. I would like for you to take a look at what we create and the progress we have made in the last several decades. And some of it is focused on Mars and the Moon. Now at USC, it's a special school. We encourage interdisciplinary studies between schools. We look at engineering and architecture and the fine arts always through the same lens. And we see and we integrate thoughts, processes, and ideas of different disciplines and different ways of thinking. My class in the fall is in the astronautical engineering department, and as usual, we have a very small student capacity of about 10 students, but our studio is full of reviewers and guests, and you will find among them champions for spaceflight like Buzz Aldrin, and we will have folks from the faculty from all over the school, as well as cinematographers. We have a variety of different engineering disciplines, and they all come to visit what new ideas we think of. In the spring, because my work is in both architecture and engineering, in the spring I am invited to teach the students of architecture about space, and the question they always ask: what does space have to do with the 8 billion people who are about to populate planet Earth? What can you do to help the difficulties and the predicaments of humanity on planet Earth? So between the two schools, we usually have some great discussions on what space activity can do for energy and architectures on planet Earth. Space technology can do a lot of things. As I heard from the earlier panel, we can provide energy, we can provide water, we can provide clean air, we can provide food, and all of it is augmented by the latest developments in broadband communications. And of course, robotics is an application that is intensifying in these years, thanks to broadband communications. With respect to people, we can help with shelter, we can help with hygiene, handle waste products, and of course, as we speak right now, satellites in orbit are helping us even now, as I talk to you, to communicate over the internet. And all of this is linked to the United Nations sustainability goals, and the Prime Minister's office has been quite active in mentioning many of those. And all of them chime with what we do in space, particularly in human space activities. As you know, just the other day, last month, the chairman of the Indian Space Research Organization came to Southern California here in Los Angeles and visited to see the manifest for the NASA India synthetic aperture radar project that is about to fly. And you will see that NASA is extremely interested in bringing India on board also on human spaceflight projects. Now, I've been discussing this with Mike Potter the other day because we are seeing tremendous developments and changes in India. And my area of focus of the last few months has been the Himalayas because the science journals have reported that activities, geologic activities in the Himalayas are changing forever climate patterns and weather patterns in India. And really looking to see how the countries, not only India, but Pakistan, China, Nepal, Bhutan, and all the way down to Bangladesh are affected by the changes happening right now because of certain glacial activities. Geological changes are happening all along the mountain ranges, and how to prevent calamities that are visiting on these populations, particularly in the hill stations and foothills of the Himalayas, is very critical to India. And there are a lot of things happening that we could study in more detail. Now, coming to space philosophies and thoughts from different people, thought leaders, in what space means is very important because the philosophy of space is critical before we act on it, particularly for humans in space and generally for humanity's aspirations of space technologies for Earth activities. Several people have proposed several ideas, and I would like you to visit these, visit the literature on these folks listed here. One thing is common, and that is when you look at all these discussions about space, underground, underwater, they all focus on one thing, and that is uh, the, the existential well-being of humanity on planet Earth. And that comes across very clearly from all these space philosophers, and it is all about how we hope to survive and thrive on this little blue planet we call Earth. So space philosophy is not new. You can go down to the scriptures, into the Vedas, and in the Maha Upanishads, they talk about Vasudeva Kudambakam. And that really is about space philosophy. And it talks about how we are all one species, and it is holistic and interdisciplinary, like the earlier panel mentioned. Many of the technologies involved currently are siloed or stovepiped so they don't talk to each other. We want to encourage that. And this is clear from happenings now. For instance, the COVID pandemic, it does not know geographical borders. It does not know politics of nations. It is global. And these things are written down in the constitutions of nations, of great nations. In the United States, it is on the walls of, of Congress, and it says, "E pluribus unum." Kant talks about in the earlier philosophies as well. All philosophers do at some point in time. So, what are some of these things we can do? We know that there's a lot of activities going on right now about removing people from the construction industry to bring up robots who can do work in a much more safer manner than people can, because human um, accidents are some of the leading causes in the building industry for all kinds of anomalies, and we think robots can do a lot better. USG has been doing some work in this arena called 3D printing. We think that we can build out structures on the moon and Mars, for instance, using robots. And robotic agents come in different forms. So some, like you see here, are humanoid, and some others are built for specific purposes. In fact, today, as I'm writing, robots are taking over the world in many ways, in areas of automotive industries, in heavy machinery areas, in power production. All of these areas have robotic activities that is also part of the new wave of what we call artificial intelligence. Here you see some activities that we are engaged in the desert, high desert, and it always involves the connection between humans and non-human agents. Some of the ideas that have been proposed in the past. And now let me tell you some of the differences between doing things on Earth and on in space or on extraterrestrial bodies. As you can see here, right up front, you can see the planets and their satellites are they come in different shapes, forms, particularly in size, and that directly affects the gravity involved in on the surfaces of these planetoids or celestial bodies. And then directly, you can see that the moon is very small compared to the Earth. Venus is known as Earth's evil twin because of the surface conditions. And Mars is a little bit smaller than Earth or Venus. And when we look at the parameters that govern these bodies, you will very quickly realize what it means to be alien. Alien means things that are not regular or ambient on planet Earth. You will see that the temperatures are different besides gravity. You will see the lighting is different. You will see the ionizing radiation on the surface is very, very different. And also the atmospheres. In fact, the moon has a vacuum atmosphere. It is so vacuum that we don't even have that kind of vacuum. We cannot even produce that kind of vacuum comfortably on planet Earth. So we have a range of differences that deal when we deal with extraterrestrial bodies. And the atmosphere, too, can be, as you can see here, that they are very, very different. In fact, not habitable. So, what's the difference between astronautics and an aerospace curriculum that we all familiar with? Astronautics deals with things outside of planet Earth. So, as I mentioned earlier, the parameters we study are quite different than we would see on planet Earth. As I mentioned, gravity, vacuum, extreme temperatures, radiation, and micrometeorites are some of the things that you have to deal with in nature outside the blanket of the Earth's atmosphere. To focus on thermodynamics, it is affected by the fact that there is no air, So conduction and convection are not available to us, and we have to do all the processes using the narrow range of radiative processes. Orbital dynamics is important, and the way you fly in and touch down on the surface of an extraterrestrial body is far, far different from how an aeronautical vehicle would fly in the atmosphere. Of course, humans are the reason and the critical element in all of these. So their safety is the priority and the critical priority in human spaceflight. So let's talk a minute about energy, propulsion, and power. The only thing that's flying now with humans on it regularly, besides a launch that went up a few hours ago to station, is the International Space Station. We've had it up there for over 2 decades, and we use solar energy. We've been using it for 20 years, and it's only now that we're debating and discussing and deploying solar in a big way on planet Earth. The difficulties, there are some strengths with it, that it is clean, but there are some difficulties, including packing factors and change of batteries and so on. And this reminds me that there is really no such thing as a free lunch in any discipline, particularly in spacecraft design and evolution. So NASA has been thinking very hard for high density power systems. And obviously the choice, I know that the last panel mentioned it in passing, is nuclear power sources. And we have been studying this for a long time, and some of them have been space qualified in the past few years. I know that the Russian Space Agency has flown some reactors, but now we are expecting to do this in a much cleaner and safer way. The Kilopower project is the first space qualified Stirling cycle reactor that is space qualified, and we are waiting for it to fly. We are looking for missions to fly the Kilopower. And then, of course, there is the next generation. We quickly realized that if we are to put humans into any kind of settlements or colonization that the session title talks about, we need lots of power. So for small projects, we are able to do with kilopower, with between 1 and 10 kilowatts of power. But as we get into permanent settlements, we need to go into the megawatts of power. And we would employ the Brayton cycle, and we can have larger reactors in the 1 to 10 megawatt class. Of course, NASA has a history in this arena. We have been flying, we've been testing these vehicles, testing these reactor systems since the early 1960s. And they included the NOVA rover program as well, right into the last few years. We are looking at nuclear thermal reactors in the megawatt class. And this is not new again, because when we started flying rocket ships, we realized the limitations of chemical propulsion, and to increase the power and efficiency of the exhaust velocities, we knew that if we wanted to increase a specific impulse, we would have to go nuclear. And so that is very much what is happening under the new administration, as well as being championed by Bhavya Lal, whom you all know. Of course, talking about India, talking about the Earth, we think we can do solar based, space-based solar power stations, and it is an area that we are studying. And we think we can also beam energies using lasers from point A to point B on the terrestrial surfaces. Of course, a lot of nations are opting for solar energy conversion devices and planning very interesting ideas. In fact, I just read that Tunisia is studying the idea of fields of solar arrays in the Sahara so that they can connect into a smart grid of sorts that is already evolving. And we're doing this in the United States now and moving it up from Canada to to the continental United States and down into South America over time. And this is one clean way of producing all the energy we need. Of course, you know that on a regular day, the sun puts out more energy than our civilizations together can use probably in a year. But that's besides the point. And of course, you may have heard that the small modular fission reactors are being qualified in the US for fielding in small townships. This begs the question about the grid and how a smart grid would operate, because it's possible to have distributed power systems available to us, perhaps in the coming decades. So that's about power. In terms of water and air, we know a few things about how to continue to use the reduce, reuse, and recycle philosophy there as well. You're looking at the scaled racks exactly the way they are put on station. They include, from the left to the right, the shower stall, the waste management area, and then the two water recovery systems, which separate both the gray water and the human waste water, and then finally the oxygen generation system. They go on the racks on the International Space Station exactly the way it is. And this is important to know because in the survival and safety of humanity in space, where there is nothing that we can look out to, open the windows, and walk out into, this is the most energy consuming part of the International Space Station. Space Station currently runs about 120 kilowatts of power, and this system that you're looking at, uses three-quarters to probably 80% of the energy on station. Now, regarding planet Earth, you've probably heard that even from the prime ministers and from my favorite Sadhguru in Coimbatore, that we are doing damage to the Earth's surface, and that is impacting how we grow our food for nutrition. And for the last 20 years, we've heard this voice coming out of different organizations. And Rockstrom's paper appeared to me that you should be looking at to see how this is affecting flora and fauna on Earth's surface. When we talk about sustainability, most of the time we're talking about economic, political, and other kinds of sustainability. But the critical sustainability that we know from space activity is environmental sustainability. How long can you park yourself somewhere and have a minimum footprint on the environment to continue to live and to thrive? This is coming up in the forefront of all space literature now. So that's about the surface. And what about once you can get a hookup or a link up with energy, water, and air. Add some nutrients, and that gives you the food that you need. And we know this. It took a long time for us to get biological systems on space station, and now we are starting to grow things on station here on analogs as well. And lo and behold, very large factories are happening on planet Earth, like aero farms, for instance. And if you go to a gourmet restaurant, most probably you're eating fresh food that is coming from a place that does not have pesticides or pests to deal with and fresh meats. Now, I'm impressed with what the Prime Minister has been saying for a long time, and this is the fact for all nations. Nations have to make their own ways because that is the way constitutions of nations are structured today. And innovation, technology is the key. There is no escaping it. Of course, people talk about technology as a two-bladed system. Nuclear, for instance, can save humanity and also wipe us out. So 2 years ago, I was at this conference when I met this person who mentioned that he was developing a first rocket launcher, and I was very happy to hear this. So Bharat and I spent some time in the hotel discussing this, and lo and behold, I was impressed how fast they were able to fly the first suborbital rocket. And a few weeks ago, I had a discussion with them. They're getting ready to accelerate this process. So India has a lot to do in the space program. And I want to bring this up again. And things have started heating up for the meeting, for the G20 meeting, of which India holds the presidency this year. And again, reminded the one earth, one family, one future that some of us have a hard time coming to because we are hooked on economics when we should really be thinking globally, interdisciplinarily. And I would like to say that many conferences are happening, and the National Space Society will be holding a conference very soon. We would like you to have that. So space technology can do a lot of things for humanities on Earth. It follows many of the things that the United Nations Sustainable Development Goals propose. And I will leave you with this thought that, as a species, we are endowed with some magical powers with which we shape our surroundings. But once we shape it, the surroundings steer us to, to do things in certain ways. So my thinking is that we should use the Taylor heuristic. That is, you should really think through the system before you do something. That is why simulations and pilot projects are helpful. And my own professor many years ago told me that in complex systems, like the ones you're dealing with supergrid, as well as with power generation and anything dealing with complex human activities, evolution, much less revolution. And this is something we're pondering all the time. Space technology is very helpful, and it always has been that once you leave planet Earth, once you go into orbit, you're at the mercy not of your nations, but Mother Earth. And this is something to remember because once you're out of Earth, you are completely global. And this is why we use a term overview effect, where people go out and they look at planet Earth and all the worries of nations and regional conflicts and sticks and stones don't matter because the Earth commands respect. So the PMO's vision is very clear. Vasudhaiva Kudumbakam. It is translated, it is shown in the US. It is also seen in the Advaita philosophy of Shankara in Tattvamasi. There are many connections to make when you're talking about space and Earth. Here are some of them, and I hope they all land in one way or the other at the G20 meetings or at the COP28 coming up in Dubai, the Space University, the International Space University, or the Moon Village Association, in which all of us in this panel are associated one way or the other. These are the books that you want to be looking at. There are several others you can look at to study what humanity can do for using space philosophy, and some references. Thank you very much, and I would look forward to any questions and the discussions with the rest of the team.
Thank you very much, Professor Madhu. That was fantastic. You covered a wide range of topics from energy systems to robotic construction to growing food in the spaceship to nuclear reactors, Stirling engines, a wide range of topics. We need a full day to talk about this. We hope we'll be able to get you physically here in Delhi soon. And I'm sure you would love to come back to Delhi at some point in time to have a physical event with us. This year, unfortunately, we couldn't. The reason being, last two editions of India Smart Utility Week were virtual editions because of the COVID. This year, we were pretty sure that this will be a physical edition. But then in the late November, early December, there was a scare that a new wave of COVID is started in China that may go global. So it may not happen. So all our preparations went little delayed, so we couldn't make it. But Samir was supposed to come, but his visa didn't get issued on time, so he couldn't. So now I come to you, Professor Potter. Please, over to you.
Well, thank you for the kind
A little louder, Mike.
And Madhu, do I come through okay from the audio?
I can hear you better.
Okay, so yeah, just once again, what an honor to be able to speak. These are such important topics. The first thing is that I'm a co-founder of Geeks Without Frontiers, which is a non-governmental organization, a global non-governmental organization that is trying to accelerate global infrastructure. We're working on that in many parts of the world. I'm also a co-founder of the Institute of Space Commerce and a senior fellow at the Institute of Space Commerce. And finally, I'm also a co-founder of the Dr. Kalpana Chawla Scholarship Project, which sends Indian women of talent to the International Space University. So unlike some of my panel members, I am not an engineer, I'm not an architect. My background is an expertise in infrastructure, but my area of infrastructure is a little bit unusual. I started off with an expertise in nuclear arms control. So my first infrastructure was really on the nuclear arms control side of things. But I have spent a lot of time working on space infrastructure and also thinking about ways to accelerate terrestrial infrastructure. And I think one of the things that people often, I believe, don't understand about infrastructure, and we talked about this morning briefly in my talk this morning, is that oftentimes people think that infrastructure is not exciting, it's not inspiring, it's in fact maybe a little bit boring. But infrastructure is fundamental for pulling humanity out of poverty. It's so basic and so fundamental, and it's a tragedy that we don't deal with infrastructure properly and on a terrestrial side. One of the things we talked about this morning was the the siloed approaches to infrastructure, where you have one monopoly provider dealing with gas, another monopoly provider dealing with water, another with power, another provider, essentially a monopoly provider dealing with railways, another monopoly provider dealing with roads. And I think if you look at space, uh, um, it's really a lesson in terms of trying to do design thinking that Madhu has just challenged us to do. We need to do integrated thinking. And, if you look at space agencies around the world, in my view, space agencies should be responsible for only three things. And number one is planetary defense. We got one planet, and if we lose it, humanity is gone. The second thing I think that space agencies should be responsible for is accelerating humanity as a multiplanetary species. And the third thing is creating dynamic ecosystems. And, we had Santosh Misra speak to us earlier. It was very exciting to hear his talk. His talk was too short, but really Santosh is talking about exponential technologies. And the problem with policymakers and lawmakers and politicians is that their thinking and their actions generally tend to be very linear. So if you're in a linear world dealing with exponential technology, almost immediately there's a disconnect. And so this is a problem in terrestrial infrastructure. And in one of the preparatory phone calls for this talk with this venue and with this group, it's unusual that you have such fragmented infrastructure. And so somebody who provides water to somebody's home has to provide billing. But someone who provides electricity to somebody's home has to provide billing. All over the country, all over the world, everybody is duplicating everybody's efforts, and they're doing a pretty bad job at it. So when it comes to space, one of the things about living and working in outer space, and if you look at the International Space Station, and Madhu gave some great images of that, is that, and as Madhu articulated, it's almost a small village, and it's a great parallel for what happens here on Earth, which is, we have water systems, we have power systems, and we have to have this, and food. We have to have this self-contained village in space, and really one of the things that I think that space can also do, and this is really more the philosophical in design, because Madhu talked to us about design thinking, but one of the things about the concept of ontological design, which is, if we can imagine it as human beings, there's a really good chance we can build it. But when we build something, and this could even be a movie, right, where a science fiction writer is inspired to write a book, and the book becomes a movie, and then the movie influences young scientists and engineers, and those young scientists and engineers build, and when they build, that re-inspires new movies. This is the ontological loop of design thinking that takes place in space, but has the ability to re-engineer how we think on Earth. It changes our thinking. It re-engineers our thinking. And so the plea that I have as we become a multiplanetary species, as we deal with exponential technologies, one of the things that we may not be talking about at this conference, which I would encourage people to talk about, is really moving from exponential tech to abundance. And one of the problems that we're going to be talking about in 10 or 15 years' time is that what happens when energy is nearly free? When energy is nearly free, it's a totally different world. And that comes from the abundance of space, among other things. But when we're dealing with exponential technologies, we're dealing with that possibility of abundance. And I think that one of the things that several things that Santosh talked about, which was decentralized power. He talked about blockchain. He talked about crypto. When you move all those things together, these are the steps to move towards abundance and power. And when you deal with abundance and power, it gets, and if we can combine that with design thinking, and we can create this design thinking feedback loop that allows us to move humanity to space, to reimagine things, to redesign things, that allows us to reimagine not a world of artificial scarcity, created by incompetence, an artificial scarcity by a lack of leadership, an artificial scarcity of siloed mentality. That is the barrier to abundance. And I think that is the direction that we need to move. So it's interesting, right? Because here we are talking about the future of space, the future of space architect, moving humanity to space. You know, a lot of people make the argument, why go to space? We have all these problems on Earth. You know, we don't have roads that are paved. We don't have power in rural areas. People don't have broadband communications. There are homeless people. Why go to space? We go to space exactly because of that. We can do both. We can improve humanity on Earth, and we can also improve and move humanity to space. So those are just some introductory remarks, and I know that we have Dr. Samir, who would like to give his introduction, and then, you know, certainly myself and the other panelists would be happy to talk during the question and answer time.
Thank you, Professor Potter. Over to you, Samir.
Thank you, guys, for the introduction. Thank you, Michael and Professor Madhu. I'm really, it brings me pleasure to be among those esteemed experts in this field. So let me just share my screen. Okay, here we go. So I'll try to make it as brief as possible because it's a little bit long. So my presentation today, I called it A Tale of a Planet. It starts telling a journey, my life journey of a research and awarded projects, both in alignment with each other in the domain of energy. So what am I doing? What I'm trying to present today? I have this line of research about designing what I call a decentralized habitation systems. What is the definition of a decentralized habitation systems? It is a kind of a habitation systems for any kind of habitable human environment. Either it is on space or on Earth. I do believe that both are two faces of the same coin. The common thing here is the human being, the existence of the human life form. So I'm trying to design a decentralized habitation system for Earth, but with the mindset of a space architect. They are totally self-sufficient and they can withstand all kind of extreme conditions, both in the present and in the future. So they are capable of resisting future challenges as well, using the local resources, of course, and that is in terms of energy, water, food, social sustainability, and also economic viability. This kind of research I have started just after the pandemic era, with what was in alignment with my space projects. So I have decided that we have to do something for the future of our planet. And here we go. So it is all about resisting any possible extinction level event, mass annihilation, existential risks. There are too many words, too many abbreviations that have emerged in the current modern life. And that is, of course, something that is alarming, both alarming, and we have to do something about it. As scientists, do believe that we have several existential risks, and my sincere apologies, this is the old list. It is only 16 existential risks. The newest one is 22 existential risks. So even those kind of lists of the existential risks are growing. Some of them are anthropogenic, man-made. Some of them are non-anthropogenic, which is natural. But the fact still is that we are an intelligent, smart life form that have to do something just to ensure the existence of our race, even in the span of the couple of thousand years to come. So that is a skill of thinking techniques that is essential. As a professor at university, I'm an assistant professor at university, I've also included what we are doing in educational environment, what we are doing to prepare the future generation of architects and engineers. So those are the set of 27 different thinking skills. This is a new revolutionary way also in curriculum, in the approaching the problem of the energy and the habitation system. So, these are the set of conditions that I have built upon my hypothesis. This is the kind of challenges that we have to include while we are designing the habitation system, even if it is on Earth. As many scientists in NASA who I have in personal contact, they do believe that Mars is the future of Earth and Venus is the past of Earth. So that means that even on Mars, it is just Earth, but it is in the future time. So it is the same habitation system that we have exist. So we have vacuum. Even a vacuum currently is a challenge in the outer space, but you cannot never be sure that this might be also a challenge on Earth in the future. Cosmic radiation, either it is man-made, like a nuclear disaster or a nuclear war, or it is a cosmic radiation that comes from the deep space. The extreme temperatures, what we are just witnessing currently is a tip of the iceberg. What we call today as the global climate change is just the beginning. So space debris, micrometeoroids, hash terrain on planetary surface, if we decided to just go to further in the tip of a mountain or on the North Pole or South Pole or any kind of harsh environment that like habitation, due to the increasing population of our race, the fast distances, the payloads, transportation the system, the lack of resources, regolith contamination, which we can just switch the word regolith and say just pollution on Earth instead. Microgravity or low gravity is another challenge that scientists do believe that we might face even on Earth. So these are the challenges, tight spaces, which is an economic viability due to the response of the economic challenges that we are facing every day. So these are a set of challenges that we as a space architects do include in our design of our habitation system, but as well, it might be the future of design even on Earth. So if we didn't act today, that will be the fact of tomorrow's design. Also, we have to include our own physical constraints. Our own physical constraints include the bone mass loss, muscle weakening, cardiovascular system weakening, vision blurring, sensory and motor functions. That means that even our race might evolve and we might change or alter our traits and physical features in the future. Of course, let me also include the psychological challenges. And all of those parameters are the new parameters for the design of the new habitation system. So my manifesto is just wrapped up or summarized in 3 sequential steps. The first step is understanding what are the nature-based solutions. So the father of modern architecture, Le Corbusier, has a very interesting quote that I would like to introduce to my work, or make it an introduction of my work. You know, it is always life that is right and the architect who is wrong. So we have to be in alignment with nature. We have to include natural-based solutions if we would like to think in terms of environment. So, digging deep old knowledge, science accumulated through thousands of years ago, when back at that time, Earth was just the harsh environment, and the humanity didn't really survive unless they have to invent passive, low-cost solutions. And at that time, of course, our energy needs, just at the beginning, our energy needs will increase, as Kardashev have mentioned, and until we reach the level 1 of civilization, our needs will grow massively, but also that comes at a cost of the pollution of our planet. So after digging deep in this old knowledge, I have to develop those values, those strengths, using the cutting-edge technology of today's technology, and I do believe you are in the link between those past years or the 1,000 years ago and the 1,000 years to come. We are in the middle link between them. We have to deliver to the future generations something that might save them, that might start their work upon and build their constructs upon. And of course, documenting and publishing those experiments in several forms. One of those forms are publishing scientific papers. One of those forms are making exhibitions or even delivering a public talk like the one we are doing today. So this is the 3 steps manifesto of my work. So let me start with the space settlements. Space settlements, I'll start with the lunar oasis. Lunar oasis is a third generation colony, a kind of colony of I'm sorry if there is a lot of noise. Can I just mute a little or decrease the volume a little bit? I hope that my voice is clear for you guys. So, Lunar Oasis is a third generation colony. It is a colony that is totally self-dependent. It is self-sufficient. It creates its own resources. Of course, as NASA mentioned in 2010, as I do believe in the paper that I've been studying, by the way, I define myself as a scientist and architect. So at the same, so that might be a science tech. So science tech is the one who is reading papers and using those papers to create architecture, and then later on turn those architecture projects after being awarded once or twice or even several times into another scientific paper to close the cycle. So this project is one of the samples. It is based on the source of water. As NASA mentioned in 2010, you have to include two main reasons to start a new life. The first one is the source of water, and the other one is the source of energy. So if you have secured the source of water and you do have a source of energy, you can start a colonization phase. So from Oasis, I have started digging and researching where possibly could be the lunar oasis. Of course, the answer will be the frozen water, which is accumulated mostly in one of the two poles of the north or the south pole of the lunar environment, and turning also to and searching for a lunar lava cave near those resources of water, and then I have found my location finally. The human psychology, do believe we have silent psychological messages as an architect. The circle represents in our human understanding the unity, the community, the family. Even in our everyday expressions, we use the word the circle of trust, the circle of friends, the circle of family inside your social circles. So, and the anthropization, which is a human typical behavior from thousands of years ago to try to rationalize nature and try to make the most benefit out of nature, like building farms or making farms on mountains. So all of those are the driving forces for the generation. And learning also from nature as a biomimicry is to understand the fundamental engineering principles of one of the most sophisticated colonization systems, which is the termites and ants colonies. And undergoing all of those research in the last 5 years, I've concluded the project of Lunar Oasis. Also, gaining another access to several papers to understand the architecture programs and the needs of a third kind of colonization, third phase of colonization, to start building the architecture program. As we can see here, this is the central plant system and the farming system that will be in peripheral of the source of frozen water, and under each plant there is a reactor. The reactor will be both melting those water and used in the purification of the water. So the energy and water comes in alignment with each other to start the new life. And those water will be used for the irrigation system and as well as for the providing the colonists or the crew members with the essential needs of water. The location, according to another research from Purdue University, I found my location in a lunar lava cave, which is 3D scanned on the image on the right. This is not my work. This is the work of a research paper that I concluded from Purdue University. And starting from here, I started to tell the story of our new race. So, having a transversal section, you can find here the central reactor, which will be buried significantly at far proximity from the habitation system and from the living zones, and at the same time it will be at the core of the, it will be drilled and it will be buried in the core of the frozen water for several reasons. One of them is just to contain any kind of nuclear disaster that might occur. I was hoping at that time that we will reach the level of having a fusion reactor. So if we have just reached that type, and I think that it is in the near future, this could be possible invention. So from here till the safe house, and I've included also 2 safe houses at the present, just in case in any kind of structural failure or pressure breach or something like that. So those are 2 pre-integrated units that will be imported from Earth and just planted on the peripheral, and the rest of the colony will be an ISRU, something that is built through the laser sintering process or the developed laser melting process, a second generation of the laser sintering process, to start building an airtight construction with an inner lining of inflatable units. So these are the typical solutions that I also included in several Sahara deserts in Middle East. So it is not very far away. But on the other hand, Sahara desert in Middle East will have a much more easier environment to access. You can access water that is not frozen, but it's on a deep proximity a little bit. But using the sand, which contains the silicon, will be an ideal solution for the laser sintering and the laser melting. Instead of consuming a huge amounts of energy for the laser sintering, we can use the solar sintering. So it is just, I'm just preparing for a line of research for me and my other colleagues to start to develop this kind of research with a target to reach this kind of an habitation system. And by the way, I was offered in 2019, and I've signed an MOU in Dubai's Sahara Desert to start such studies. In maybe, hopefully, in the future, we can build something like this. So, including or talking about the SRU, also science can intervene here to provide us with innovative solutions. Instead of using the block mass which might contain some internal cracks by the time due to several kind of loads, a lesson that we have learned from space architecture. You have accidental loads, you have pressure loads, inner loads, you have gravitational loads, you have all kind of loads. So the answer was in another research from MIT in using the minimal surfaces or the gyroid cubes. The gyroid cubes is a very ideal cube. It can resist 6 times more loads than the solid cube, and at the same time it contains all kind of thermal pockets that might act as a thermal insulation to resist all kind of thermal swings in the outer environment, and hence it can also decrease our consumption and need of energy to cool or to heat our interior spaces. So this is the construction roadmap. As I've included, even also I tried to, at that time, of course, very primitive prototypes of the excavator and the laser sintering process, and even started to calculate the amount of energy based on the volume of the laser sintered sand. And here, I mean, with the two solutions, either on Earth or either on Moon. I do believe the common here is the comfort of the human being. So it works in alignment with both solutions. Turning to the energy solution, or how to power the colony. Here, as an architect, not as an engineer, of course, I've included several kinds. The diversity of energy solutions was a key element in design. So the first phase will depend on the solar satellite or solar-based energy solutions, something like the solar satellites that will be beaming a low energy, low wave microbeams or even laser beams to start providing the colony with its needs of energy. Until it will be switching to the reactor at the core. The reactor will start providing, at least for like 60 plus years, the energy needs of this village. Either it is a lunar village or a solar age, but also we have to include the human part, the humane part, which is the piezoelectric flooring, so people can dance, can exercise, can have all kind of fun, and at the same time they will provide energy. And that's the of the interior solutions. So we as our architects will do believe that it is very important to include a habitable zone, not just to perform your daily tasks, but to live in. A place that you can call home, and you can you have a countless number of memories, pleasurable memories, instead of counting moments to return to Earth. And last thing is the hygiene and the psychological well-being. The clean zone. The clean zone is an inner courtyard, and it is something that also learned from the Middle East classical and ancient kind of housing systems. The courtyard, it will be vacuum cleaned from all kind of regolith and dust, and luckily the lunar environment doesn't have any kind of atmosphere, so at the same time there is no wind dynamics, which means that there is no transfer of a regolith from one place to another place. So the inner courtyard will be the clean heaven to include all kind of sessions. People can stretch their legs. They can just overcome the phobia of the tight and in narrow spaces. They can have their own park and enjoying the inflatable structures, which will be including the trees inside. This project has been awarded 3 times. The first time in 2018 in Jacques Rogeri Foundation, and then later on it was turned into a scientific poster in the United Nations Office for Outer Space Affairs in 2021, and last award was in Ukraine. Hopefully the war ends soon, just to resume our activities. It was turned into a VR experience, and after this massive success, I started developing from the lunar oasis to the Earth oasis. It is the same solution, it is the same habitation system with the same values, but as Earth is a much easier environment than lunar, that doesn't mean that it will make our task as designers and architects and engineers easier, but that means that we have to develop it furthermore to a much more developed solution. So not only that we have included several limited kind of nutrition production units, we have just thrived into all kinds of farming solutions, hydroponic solutions, aquaponic solutions, included even marine life inside the new solution. That was part of the presentation for the Dubai's colony. So we have the lunar colony and Dubai's colony. Of course, you can enjoy the sun and the wind and all kind of Earth representation, but also we are building something for the future. You can consider this as the 7th or even the 8th kind of smart cities. You can contain your greenhouse, the inflatable greenhouse inside a controlled environment to give or to provide them with a new kind of nutrition, even if it doesn't suit the local environment. So that was the new part that we wanted to include in. The inner space will be the crossroads of several parallel universes. It is the first notion of metaverse. That will be the meeting ground that even your parents, your friends can meet you. Either you are on a lunar environment or in a remotely desert place. So we can use the experience of several experts in several parts of the world on the globe, meeting in the same space using the VR technology and the metaverse that will be developed in the next year, according, of course, to Mark Zuckerberg's promises that this will be an available technology and it will be democratized to be available to all people. So I would like also hopefully to use this kind of technology, not just for fun, but for keeping our race in essential good shape. Another version that was developed in 2019 and that was awarded in Malaysia, Kuala Lumpur International Architecture Festival, the Martian Oasis. At the Martian Oasis, you will find that there is a high resemblance between the Martian Oasis and the Lunar Oasis, but of course, due to the significant environmental difference in environmental parameters, you will find here that there is also a response to the new kind of wind and even the sand winds. So the trees, the inflatable structure of the trees are now equipped with long fins of the MSA or memory-shaped alloys, the methanol, which can respond to any slight vibrations from the wind and generate energy using the piezoelectric energy as well. So if even on the Martian environment, sun is blocked, and that might affect the growth of our plants, but at the same time, the movement of the wind, the sandy wind, which will block the same sun, it will be also the same reason to start generating energy with using the piezoelectric energy with a memory-shaped alloy that can resist all kinds of deformations and return to its original shape. But at the same time, those energy will be used to lit the inflatable hydroponics to provide all kinds of plants and flora system with its essential needs of light for the photosynthesis process. So that will sustain and maintain the green element or the vegetation essential for nutrition, for pharmaceutical needs, for gadgets and basic needs like furniture and cotton and medical needs, and for various future needs, even we can include some trees which might produce the biofuel. So it is turning from one energy and growing our own energy in our courtyard. This is just a quick comparison between the lunar oasis on the left and the Martian oasis, and luckily we will also include the Earth oasis, which will be in alignment with the same values and much more developed for our Dubai desert environment. This is another section which you can find it is totally significantly different from the lunar oasis. Now we have very long air shower airlocks. Now we have a hierarchy in the habitation. The most secure part and the most shielded part will be the living zones, and then the working zones and the food preparation unit and labs, which will access all of the vegetation system from below, and 50% of them are buried and 50% of them are just above earth using the ISRU, or the in situ resource utilization, having some parts of a semi-transparent or translucent 3D printed parts for the circadian rhythm, and to ensure that this will be lit with a daylight system to minimize the need for energy consumption, and at the same time for the physical and psychological well-being of the human habitation crew for the circadian rhythm, to ensure a circadian. There's also 2 layers of air showering and airlocks, just to make sure that most of the part of the day, this will be the usable space, so it needs the highest degree of protection and decontamination solution. You will find also that there is a nuclear reactor that is included in the solution that will be the main provider of energy, but there is here a decentralized system. So those trees will not be needing any kind of energy from this reactor, but in case that they need an extra energy is just in failure of environmental generation. You cannot control the wind or the sun or the environment on Mars, but you can contribute to the main grid pool of energy. So it is a decentralized system, but they are all pouring in the same pool of energy. This is the phases, of course, this is the automated phases or the autonomous phases of building and boring the colony before the human presence. At the end of phase 4, which is calculated at the span of 5 years, using all automated robotic system with the artificial intelligence, which will be powered by both solar-based solutions, which will be beaming directly to another station, secondary station on the supersurface, which will be beaming to the robotic to start the boring and the 3D printing and laser sintering. And at the final phase of the 4th phase, that will be the time for the human presence and the human arrival. This is just a depiction of what it might look like. Of course, you have the 4 cardinal gates in alignment with the north, and the Martian south and east and west north, and very pleasant and well lit, and also including the solar array panels in the perimeter, in the outer perimeters, which also will contribute to the general pool of energy of the same colony, the diversification of colony. Now let's just move to a particular part of both of the previous project, the Tree of Life, the inflatable hydroponic system. This is also another project that was awarded in Los Angeles in 2017 in the energy category in Mars City Design Foundation. So that include that the main source of inspiration actually was gained from the fact that Mars might have a very heavy sandy storms that might cover all of the surface and might prevent the photosynthesis process of trees. But at the same time, those winds might give us the opportunity. That opportunity will be in the movement and the dynamics of the movement of the wind, which might be gained, harnessed, and used to generate much energy for the units. As I have mentioned earlier, the vibrations of those long and very long and thin fins that were designed by the waves in a twisted, flat sheet of metal, the memory-shaped alloy, just to accept the movement of the wind from any direction and start vibration. And by having all of this wind, it will start each inflatable hydroponic will have beneath a battery and a generator to just start generating the energy, and at the same time saving and that energy for further need. At night, at 24/7, it will be generating energy and storing this energy and saving this energy for later needs. Another depictions of the solution. That was the first phase that started developed in 2016, and later on it reached the final level, of course, after several workshops with several senior engineers that served in NASA for more than 10 to 30 years, and after some calculations and some readings from some books like The Hidden Life of Trees, which gave me the fundamental understanding that there is a high network and there is a conversation between all of those trees, which inspired me in the energy grid solution. So each tree that have an excess of its energy, it can share its resources with the other tree. So that gave me the idea to start building a network of energy between all of those inflatable hydroponic systems. Moving from this solution to the last solution, which will be portable according to the dimensions of the payload that is available at our current time, to be transported from Earth to the new environment, and as well from a station on Earth to a remote desert station if we needed to use someday this kind of solution for a harsh environment even on Earth. You can find here at the left part of this slide an extra inflatable unit which will store all kinds of nutrients that might serve the process of this tree. And then, of course, this is a zero waste solution, not only a zero energy food generation unit, but it is also a zero waste. So it is a mere representation of what is known as the circular design, or a circular economy-based design. These are the first prototypes that we have tested just to dust off all kind of regolith. It is a pointed and long, elongated shape inflatable hydroponics. And the contoured lines on the surface are the wires of the LED strips that will provide the plantation system or the vegetation system with its main necessities of light, just in case that there is no sunlight to provide it. Also, sunlight on Mars is problematic a little bit. It is only a 60% of the sunlight exposure on Earth. So that means that if we imported plants or trees from Earth to the new environment, even at the sunniest day of Mars, it will be insufficient for those trees. So we have to include an extra secondary solution to provide them with the light and even the energy that might be needed to maintain a thermal balance inside the interior environment of those inflatable units. By the way, those inflatable hydroponics is a double-sided ETFE with an aerogel insulation just to decrease the demand of the energy consumption even for those trees. That was the site in 2017. That was designated for a prototype, but later it was delayed a little bit, the building of the prototype, due to some funding issues. But hopefully I'm still working on developing it. Later in Dubai, this is another solution that has been also awarded in 2022, as I do remember. This is another solution in 2020, lunar space elevator, also another solution to try to build something. Of course, lunar space elevator, or the concept of the space elevator, will be much more easier and maybe financially and scientifically and technologically feasible on the lunar environment due to the decreased gravity of Moon. It's only 16% of gravity of Earth. But on Earth, even if this is a declared and announced project for several companies, like in Japan, in Dubai, they have announced that they are future plans of building something like a lunar space elevator, an Earth space elevator, but I do believe that it is much more easier and much more feasible and much more crucial and important on the lunar surface. This will be the first railroad system that will enable us to transfer the nuclear fuel from the helium-3 fuel from the lunar surface to Earth. That will provide us with with our growing demand of the helium-3, which is needed for the reactors on Earth. So as our first colonies on Earth, just transporting resources from uninhabitable environment like Moon to a very congested habitable like Earth with a growing population and growing demands of energy, this might be a crucial solution. That might be a saving solution of our needs. It will serve as an internal transportation system and an external transportation system. If we are discussing about the external transportation system, it will be the main link with a very low-cost solution to link Earth with Mars and even deep space. habitation. It will also serve as a scientific facility with a deep space telescope. And at the same time, it will be connected to several remote parts of the moon as a structural consolidation of the same lunar space elevator, and at the same time it will be a secondary, sub-secondary transportation system for several nodes. So that will be the main hub that will be connecting several parts of moon. And underground here, there is the facility or the plant that will be excavating and collecting and later on shooting that helium-3 packages to Earth. That is just the parking or the docking area. Of course, this is the old classical Saturn V, which will be replaced by hopefully the SLS, or maybe a new invention that might occur in the few coming years. You can find here also an array of solar panels. This is also another solar-based satellite, but this is not a satellite, it is a connected and fixed to the body of the lunar space elevator. So this is a geosynchronous station, which means that it is moving in alignment with the same location on the lunar location or the point, so it can access all kind and harness all kind of solar energy and start to provide the colony with its needs. At least it will be providing the vehicle, the transportation vehicle, from the geosynchronous station to the subsurface station. That is the depiction of what is known as the industrial moon mining facility. That will be the starting point of the lunar or the space economy. It might be the fifth industrial revolution, considering that the fourth industrial revolution will be based on AI. I do believe that the fifth industrial revolution might be the space economy. And economy means capital, and capital means investments. And to be luring to these investments, you have to give them the understanding that there's huge and massive resources, and especially the energy resources, including the helium-3 resources, which is accumulated massively on the lunar moon due to the lack of the environment, atmosphere on the lunar surface. Of course, let's do not forget fun, the human part. So importing part of Earth and depicting part of Earth, the anthropization or the rationalization of part of nature, trying to build a balanced and equilibrium micro ecosystem, including all kind of flora and fauna system that might be working in alignment. And of course, as we have learned from our past thoughts that we cannot control environment might grow wild in a certain moment that so that this should be monitored and controlled and administered by an AI system, computerized system, just to ensure that this will stay as a zero energy environment and zero waste environment, and at the same time a self-sufficient environment. So we will be producing our own food, our own excavating our own water, and not having the water only for irrigation or for drinking water, but also for having a pleasant environment that will answer all of our psychological needs. The problem of engineers, most of the engineers that I've worked with, working in space, that they only think in the physical needs of the human body and not in the community needs. So the community needs might include that at some point, if you have just kept those community members in a confined environment, there will be a risk of committing suicide, or even the risk of a mutiny, or a risk of all kinds of community problems. But by delivering them a pleasant environment, a place that mimics Earth and even might grow to be a new kind of an environment, a new kind of nature, a nature that is only can exist on the lunar surface, that might answer our psychological needs, which might sustain and maintain our existence in the extraterrestrial environment. And the same might go, let me remind you all, that the same might go on Earth in a case of an existential risk in the future, according to scientists, with the 16 different existential risks that I have discussed earlier. So, moving from lunar, and of course the biomorphology, this is the selected site, by the way. I do select all sites that is consistent with the geometry and the project. So we don't need to bore, or we don't need to excavate. This is just pit crater. Of course, pit crater might probably include high reserves of frozen water inside. So you just be capping that pit crater and start building the lunar space elevator. The key of life is another satellite solution, which will be deployed from the whole distance from the moon to Mars, and this will act as gas stations. It will be beaming low energy waves or laser waves that will be harnessed and stored inside this torus-shaped satellites, and it will be beaming all of the expeditions that will be going forth and back from moon to Mars and from Mars to moon. And this is the very long antenna, and these wings, that is the solar array that will be deployed to start harnessing all of the solar, and that will be the storage unit that will be beaming the energy. And so this is like a floating facility, a floating energy plant at the same. It is a satellite that is dedicated not only for communication or for navigational guidance, but for providing energy, beaming energy to the next generation of space vehicles that will be moving and transporting goods, resources, and even human beings in the future. That is a designated locations of the orbital satellite from Earth to Mars, and it might increase, of course. That will enable us to start building what is known as the Space Silk Road. So it is also a depiction from our past, something that I have derived from the ancient Silk Road, which connected the East with the West. But now it will be connecting Earth with Mars. Of course, this is a very deep human, this is a human iconic image that you can find in nearly each kind of civilization and ideology, the winged sun. So this winged sun, it is the same as I have called the key of life satellite, the energy generator and the energy storage unit. Of course, it might also be developed into another version, which might act as the infrastructure for the Martian environment. It will be the first kind of infrastructure that will be collecting and harnessing all kind of solar energy, and of course, due to the lightweight and the member-shaped alloyed designs of the solar satellites, so no accumulation of Martian dust will be on that surface. So even if there's any kind of accumulation of the Martian dust, that might decrease the efficiency of the solar panels, using the piezoelectric energy on the other way around, which will provide or will give those solar panels some kind of a vibration to dust off the Martian regolith. So to ensure the longevity and to ensure the sustainability of such an infrastructure unit, and at the same time, it will be beaming all kind of energy to the different colonies that might be existing in the future. Turning to the recent project, which is 2023, and using some aid from Open AI ChatGPT as a counselor, as an advisor, I started developing the last project, which might be also inspired from one of the most sustainable and most resisting to all kind of existential risk kind of life form, the coral reefs, which is built also from the concept of the ISUW, or in situ resource utilization, and it includes inside it various life forms. So also understanding and learning from our mentor, the nature, and start to reflect those lessons into a habitable environment through a very long process, and depicting text image generators to understand the specific type of coral reefs, which is called the brain coral reefs. The complexity and the sophistication of such a life form adjust, and of course, by the rationalization, understanding how can we rationalize such a natural-based form into an engineered and architectural colony. And it included 5 steps, starting from understanding what is the basic shapes and elements, and the understanding or rationalizing some kind of shape grammar rules for expansion in terms of scale, proportion, and orientation, and the structural stability, aesthetics, and functionality, and reaching to the final degree of communicating the design through drawings and models. And I start building the vocabulary, the new language of nature, trying to rationalize that element from nature into specific alphabetic system. This shape vocabulary or shape alphabetic system, which includes its own shape grammar. This is the approach. And from that methodology, I start making the first prototype of colony that might maneuver around any kind of geological and geographical features. One of the main challenges that I've included at the start of this presentation. So even if we are facing a harsh geological or geographical features, even on Earth, we can overcome that by taking from natural-based solution and rationalizing the nature from just a random or what we think as a random form morphology into an engineered kind of morphology. And these are the 5 rules, even working with a complete unit or a half unit. But this is, of course, an ISRU system, which will be built using the regolith, the local regolith, but at the same time using also another AI system to start understanding what is the Voronoi structures and what is the most suitable Voronoi structure. And from here, start building the colony. You can find also the same solutions of very long posts. Those posts will be also the piezoelectric posts vibrating and generating energy from the Martian wind. And at the same time, you will find here later on another solution trying to understand what might be the interior environment that might be pleasant for the human crew members using another AI system. This is not my visualization. It is just text prompting engineering. And the resulting solution was interesting enough for me to start making some exposed area and semi-open air, semi-enclosed areas, which will be ideal for parking of all of our rovers and vehicles. And until now, you didn't find the habitable zone. The habitable zone will be built inside and buried inside. This is a pre-integrated units that might be imported from Earth and start to be built upon with the regolith. So also using AI again to understand what kind of connections that might be. So I tried training the AI system to give me solutions that are derived from the air conditioning ducting system, because this will be a very long habitable zone. It will be something like, the old mid-age kind of villages and cities that their streets are like the maze. This is just a depiction of our starting. That will be our mid-age, but on Mars, not on Earth. So the high technologies on Earth that we'll reach will enable us to start a new life, but it will be in alignment with the same human behavior in the developing of urban spaces and cities, even in the extraterrestrial environment. So solutions are generated. Those, of course, are excavators that will be developed by NASA. This is my imagination, or this is my invention of having a 360 laser sintering process with a high tanks of filtered regolith. So by building the main foundation and then start to insert the pods, the pre-integrated pods, and then start enclosing them and totally covering them with a 3D printed regolith that will be protecting them from all kind of radiation and thermal swings and all kind of challenges. And of course, the generators will be inserted between them, so to generate and to provide all kind of energy that is needed. But turning also to the inflatable units, the food production unit system, which will be accessed also from below with 4 sequential steps, finding the pit creator. And of course, I didn't talk about the selected site. The selected site was chosen carefully to understand that there is a Martian Martian lava cave beneath it with several pit craters that might be the connection from the subsurface to the supersurface environment, and start covering them and reinforcing them and burying them. And at the last, it will be popping up all of the inflatable hydroponic system that will gain the solar rate for the plant. And at the same time, you can find the fins that will be vibrating by the piezoelectric energy to generate all needs for those greenhouses on the Martian surface. This is just a prototype of the beginning of the enclosed capsule that will be popping up and start to opening, and then the inflatable unit, and it will include all kind of nutrition and models, and it will be administered and managed from below. So the food production unit will, in the central part, just to have democratized access to all residents of the zone at the same time with the equality in resources. So it is the center of a circle with the same radius to each neighborhood of this colony. You can find the main planning area that I've included also the kilo power units that will be the main source, but I have included it in a remote area. That will be the launching pad of SLS and the solar-based solutions. So also I have diversified in the energy generations, and also the piezoelectric antennas. So we have like 1, 2, 3, and even 4 different solutions in the energy. That was awarded in Paris in December 2023, the Grand Prix, and next year I'll be serving as a judge member in this international competition. After 7 years of winning, they have just concluded that I shouldn't be entering this competition anymore, so I was offered with the Minister of Scientific Research, Madame Claude Auguin, and former cosmonaut in French Republic, to serve as a judge member next year, luckily in December 2023. So, turning from space to Earth, we have to develop and learn space technology. We need it someday on Earth. So those are several solutions, several habitation systems, not for Martian environment, not for the lunar environment, but for Earth. So those are different solutions. I don't have the luxury of time, of course, of presenting all of those solutions. So I'll just brief it. Simplicity is the ultimate sophistication, as we have learned from Leonardo da Vinci and what we have learned also from Apple design code. So for building something that might look like it is so simple, it must be of an ultimate sophistication. So this kind of sophistication that will be presented. And here is the I house, or Fina house, which means the courtyarded house. This minimalistic form of house will be a house that produces its own food with a hydroponic unit, and also something that we have learned from the old civilization and old communities here in Middle East. This is a pigeon tower or bird's tower, another viable and vital source of protein for those residents, with the hydroponic system, a water collection system, and a fog net system that will be providing its essential needs of water. And of course, you can find the solar array of panels at the rooftop, which will be providing them with all needs of energy. So it will be producing, this is a decentralized system. The mean of a decentralized habitation system that you do not need, if you wanted to, you do not need to go to a grocery store to buy your food. You can produce your own food to resist maybe a possible scenario of a pandemic or any kind of dystopian scenario in the future. So you can be producing your food. This will be your workspace and your living space. You do not need to go out if you didn't want to. You can provide your own energy, so you don't need any kind of central grid for governmental electricity grid. You can make your own energy, and even you can sell your own energy to others. This is the next generation kind of habitation system that I'm trying to develop through scientific research and projects at the same time. Those are the 50 design criteria that have been included at this house. So this simply minimalistic house, it doesn't really function as does it look. It is really a very wide and minimalistic, but it is very sophisticated. 50 different design criteria that was forged during the last 10 years of my life to reach this solution, through 5 different scientific papers and publication in Q journals, and through 15 different international awards on Earth architecture. That is the strategic thinking that also I've included. These are the community that will be rethought and redeveloped into the new house. So we have extreme kind of poverty, extreme kind of pollution, extreme kind of scarcity of nutrition system and water, and there is no clean water. This is what I called a harsh environment, but a harsh environment on Earth. This is our harsh environment, something that might be in the global south countries or the underdeveloped communities. So this is a solution for those. But at the same time, those communities have taught us that they have values. The courtyard, which is the social container of the environment, the pigeon's tower or the bird's tower that provide them with the essential protein and form. So those are the values that were included in the new design, and understanding the importance of decluttering your spaces in your psychological well-being, also another lesson that is learned from the minimalism movement, and all of those was included in the new house. I'm sorry that I'm just running a little bit quickly, so it will include fog nets, a biophilic design. It will embrace different kind of biodiversity. It will enable the passive cooling, so there is no need for any kind of electrical or energy-based cooling. This is the fog nets, and of course, according to the basic calculation, it will generate up to 25 gallons per day due to the early morning dew and fog during the whole year. it is a very fog. Also, the cultural expression is something important. If you didn't give them solution, they will try to make their own solution. So the diversity of the local communities, it is a relationship that might be called a unity within diversity relationship. There is something united. The values, the core values are the same, but the diversity in the cultural expression. This is the International Space Station Life Support System. This is the same diagram that was simplified to invent the new Earth habitation system. It is something that is based on the zero waste, circular economy, circular resources, maybe. This is the same study that I have tried to simplify for the new kind of habitation system on Earth. This is the food production unit, which will include the hydroponics, the pigeons tower, and will act as a stair and will act as a wind catcher, which is something that is important for the cooling. And at the top here, you can find the main stormwater collection unit. So this tower will serve as the main core of life, providing life to the whole of the unit. It will be giving water, clean air, green, and even protein. And at the same time will act as a vertical circulation system. Of course, some of the scientific simulations, just to ensure that this will function as it is designated to be and as it is designed, and some of the previously developed piezoelectric and water collection system, and depending on some previous studies from the same area, and start experimenting also, again, the TFD simulation technologies, just to make sure that the wind and the passive solution will start cooling as it is designed to be, and the basic calculation of the electrical energy according to the solar exposure also, and giving them several solutions, either it will be on the roof or on the facade, and trying also to give them fun. As all of our projects, this is also another solution that is derived from the pop art of the local area that was simplified into 4 basic colors and were introduced into a lightscape study to give them solution that might express fun. Of course, a low cost and low energy led solution, because fun is essential as food. Fun and psychological support is important as water, and it is essential for life. Giving them the adaptability and flexibility, giving them several urban scenarios to fit in any kind of possible scenario in the harsh, dense city or in a rural area, or suburban rural area, whatever. So this is a depiction of the selected site, giving them 1 floor or 2 floor solution, or even it might grow vertically and it might expand also horizontally. It is a modular solution. Also another lesson that is learned from the space architecture, how to understand modularity, how to design a modular solution. That is the scientific thinking in approaching an architectural problem. Further studies were conducted also to understand how pressure and humidity and even wind will act, and this is a work in progress, even after it has been awarded and gained the first award, but I'm conducting further research. Another solution you can find, of course, the top roof with a complete farm, hydroponic farm, and the solar arrays. And this is an Arizona house in the United States, even in the United States desert, which is considered to be a harsh environment, but you can make a decentralized habitation system. It's a habitation system that I've mentioned, the voxel house, a future also version of a house that can ensure all of its needs, even it can embrace the future needs that doesn't exist today, using the metaverse, using the Web3 based technology and the blockchain technology in its design. You can control your room needs even with a small application on your mobile phone. So if your family is growing, you can start also including new rooms, new spaces. It will also cultivate and farm its own needs from vegetation, and it will be administered with an AI robotic system. You can even open your own entrance using your mobile phone, and then just closing it, you can enter from any point at the perimeter of the same habitation. It is a new form, a future form of the decentralized system. Another house that is designed for German rural area, town called Cottbus City. This is not a glove, by the way. This is another material called ALON, aluminum oxynitride, transparent aluminum. But it is equipped with a semi-transparent, or a transparent, Solar panels, another inventions that will be developed by MIT. So this is also a very secure post-pandemic house, and you can find the rooms are color-coded. You are just sitting in front of nature. I can't really explain each detail according to the limitation of time. Even public buildings. So this is a temple that is all covered with a piezoelectric flooring. So this is another cultural expression to the society. This iconic mark was designed for Dubai. So it is also the more the people enter the temple, the more the energy that will be generated. So if you would like to light your city, you have to have some faith. So this is another cultural expression that is intertwined with the energy demand or the energy generation. So it is not only engineering, this is architecture of the future. I'm sorry for taking a little bit longer. I'm not sure of my time. This was my journey. I'm sorry, this is the old number. I've included this year my 42nd awards. These are the cities that I've been awarded in different places, in different areas. These are the exhibition map. Next April, I'll be pinning another one in Germany, and another one in Italy this month, and then the next couple of months. And this is one of the main exhibitions. I have participated with two projects, the Tree of Life and Lunar Oasis in NASA Johnson Space Center, 2019. And virtually making also exhibitions for the K-12 students. And this is part of my manifesto, is to prepare the future generations. I do believe that we should be leaving them something. Even after our passing away from this earth, I do believe we have to leave them our legacy and not to prevent them or depriving them from any science or knowledge. Democratizing what all of I have done for the future generation will be the form of sustainability of our knowledge and our traditional knowledge system. These are some of the publications that have included my work, luckily. These are some of the interviews. These are some of the platforms, from NASA to Discovery UK channel, from Forbes Middle East magazine, L'Architecture d'aujourd'hui in France, in Paris, Arch Daily Design Boom, Biblioteca Alexandrina in Egypt, L'Arca Internazionale in Italy. These are the workshops maps. I, as a professor of architecture, I have also to serve and educate people and teach them how can they design for the future. And from Canada to Uzbekistan to Tashkent city, I have been luckily spreading this new form of decentralized thinking. School of thought might be the right word. These are some of the papers. I would like to finalize my presentation today by the three consistent quotes that it is no coincidence that they are so resembling. The first quote goes like this: the future belongs to those who dare to dream, even if we don't have the technology. But later on, Eleanor Roosevelt also have concluded its quote: the future belongs to those who believe in the beauty of their dreams. So that is our faith, that we have to complete our journey. And finally, with Malcolm X, the future also belongs to those who are prepared for it today. So just to turn your dream into a fact and reality, you also have to include those through three quotes in your life. Thank you all for having me today. Thank you for bearing the time and having the time to hear me to my presentation. Those are
Fantastic, fantastic, Samir.
Welcome. I can send you whatever you'd like to. We have even, you can pass by to say just hello or hi. Thank you.
One of your slides said, one day we need to move out of Earth. So how soon? This decade, this century, next century, how soon? And also, one thing I noticed from your previous talks, which I heard, biomimicry strategy, which you are talking about now, is something new. I have not heard in your previous talks. And 3D printing and prototyping you mentioned, which is real. Where are you doing? Could you please tell us?
I'm sorry, I'm facing some difficulties in the hearing. If you kindly just adjust the
you couldn't hear me? Can you hear me?
Yes, please. Yes. Now I can hear you well. Just if you can repeat slowly, I would be
You
thankful to you.
mentioned in one slide that you are doing some of the structures, 3D printing and prototyping, which is real. So where you doing that? Where is it?
Well, prototyping is part of the scientific process. As I've included, I'm a scientist. I do define myself as a science tech. Science tech is both a scientist and architect. So I do design as architect, but at the same time, my client isn't a real life client that will be paying me fees. It will be science and the future generation. Those are my clients. So I am turning those architecture projects from, I'm deriving its data and the brief from scientific papers and turning those scientific papers into a physical manifestation in a visual form. And then later on, just to write my new paper, I have to prototype those. The funding resources of my research and my work is from my university, from several research grants, and hopefully in the future also with my own company that I'll start soon. I hope that I have answered your inquiry.
Madhu sir, Professor Potter, any questions from your side for Samir?
No, I think it was a fantastic tour of, how do you build communities and how do you build ecosystems. So thank you. We appreciate
louder, Mike.
Thank you,
Louder?
Professor Michael and Professor Madhu. You are so kind. And really, I'm honored to be among you guys here today. It brings me pleasure to be among those bright minds. You are the best in your fields, as I believe that.
Please share this deck. We have Madhu sir's deck already with us. So, Professor Samir, you also share the deck, which we'll share with our viewers, audience. The recorded video of this last 2 hours will be uploaded on our YouTube channel in 2 weeks' time. And we hope to have this session physical next year or maybe even before that. We hope to have you
I'll make
all
sure that next year I'll
in
be
person here.
I'll prepare from it from this day.
Any last minute comment, Professor Madhu, Professor Potter?
Well, thank you for the invitation to present and to hear a little bit of the discussion at your conference, Reggie. It was, I think we tuned in just in time to get the tail end of that last panel. And that was useful for me to gather the ambiance that you brought to the gathering. How many people are invited to this meeting, Raji?
During the day, we were discussing about the grid. That time we had a lot of people. Now there are less people, but this will be the video when it will be uploaded. There will be hundreds or thousands of views over the next months. So some of the key people, they will be going through the slides. So we will be promoting all these sessions. Session by session, we will be promoting once the videos are uploaded. And this all over our social media of us and as well as our partner organizations, supporting media organization and all that. It will have a very wide coverage.
Yeah.
And thank you very much for waking up at 4 o'clock in the morning.
Thank you.
To Madhu sir and Michael sir. And Samir, thank you very much, and we'll look forward to seeing you. So I'll meet both of you in USC first week of April. Once my program is final, I will write to you and look forward to seeing you in California.
Sure.
Thank you.
Okay.
Good day.
Very good.
Good
Hey,
night.
thank you.
Thank
Really
you.
Yes.
Thank you all.